Yeah.
Record it and then play it back, because it might not.
That's true. All right. This is the tip path plane that is used in the helicopter aerodynamics. As you can see, it's one single plane. See right here. This is also why this is called the disc area, because as the rotor spins, the disc is made out where you can see. And when you tilt the helicopter swash plate forward, you can see the tip path plane tilts forward just slightly as the stabilizer bar goes into the tip path plane but does not hit the rotor because of the angle. And as it tips backwards, you can see the tip path plane tilt backwards slightly. All it's needed is a minor adjustment in the angle for it to move. And if I can get behind it, you can see if you tilt it to the right and then left, how the tip path plane goes in the direction of the swash plate. The swash plate is down here, right here. Move the swash plate around. You can see forward, backwards, left and right. It follows the direction of the swash plate, which hooks up to your turbo. So the same principle as in a regular helicopter.
Yeah, it's good.
We'll talk about the phases. Talk about the phases. We'll go. As we slow down the rotor, we can show you how, as the rotor spins, this side is getting the lift as it spins. This side is getting the lift, and this side is stalling. You want to talk about anything? Okay. So, as you can see how the blade, you can see the lift, the profile of the blade. It's a symmetrical airfoil, and at a 0 degree angle of attack, it's not going to get any lift until you tilt it. And any input on the swash plate is always 90 degrees out of phase. So, if you tilt it left, it's going to happen here is when you're going to get your input. It's always going to be 90 degrees out of phase for a rotor. This is the stabilizer bar. This always wants to self-correct itself. If it gets anywhere out of balance, it always will correct itself. It's like a gyro. This is like a gyro.
These are called lead lag hinges. As you see, the blade actually is able to lead and lag. And you also have pitch bearings on here, which allow the blade to pitch up and down. This is the pitch bearing is in here, and this is the lead lag hinge. This helicopter does not have flap hinges.
Yeah. And the lead lag hinges are so if it to show you the lead lag, it'll go like this, direct like this, in order to stabilize the aircraft and not transfer any of the forces to the helicopter itself, causing it to be unbalanced and hard to control. All these hinges help the pilot stabilize the aircraft easier. And that's pretty much the basics of a rotor system on a helicopter.